Good afternoon to one and all. Myself, Professor Dr. R. N. Mulik. I am going to take the fifth chapter, third chapter of elasticity of paper 5, BSc second semester third. Now, in general physics includes all the chapters related to general physics. The elasticity, the content of the chapter is in basic introduction, then bending of beam, bending moment, cantilever, centrally loaded beam, and then flat spiral spring. As far as the introduction of this chapter is concerned, elasticity is the property of the material or of a body due to which the body opposes any change in its dimensions whenever deforming forces are applied and regains its original dimension as soon as the deforming forces are removed. When you apply the forces on the body, the deformation in the body takes place. If you remove the forces, external forces, the body will regain its original shape and size. Such type of the bodies are or materials are called elastic material. When a deforming force is applied to the body, internal restoring forces is developed across the body. The internal restoring force per unit area is called stress. Because of the internal force and applied force, the deformation in the body takes place, and because of which the restoring force per unit area is called as a stress. The body is subjected to the stress because of the external force applied on the body, or the internal restoring force is developed across the body. The ratio of change in dimension to the original dimension is called strain. The two quantities were come across the elastic bodies when first force per unit area, that is called stress, and because of the stress, change in the dimension of the body takes place, which is counted in terms of another quantity which is called strain. The ratio of change in dimension to the original dimension is called strain. Within the elastic limit, the ratio of stress to strain remains constant, and this constant is called modulus of elasticity. When we study the elasticity, we come across different elastic constant. Very first constant is called modulus of elasticity. How this modulus of elasticity is defined? Within the elastic limit, the ratio of stress to strain is constant, and which is called modulus of elasticity. Then we come across the another behavior of the elasticity, that is bending of a beam. As far as beam is concerned, beam is a rod or it is a bar of uniform cross section of homogeneous material whose length is large as compared to its thickness. A long bar of around 1.5 meter length, which is prepared from a homogeneous material whose length is large as compared to its thickness, such type of the bar is called a beam. When one end of the beam is fixed and another end is kept loaded within the elastic limit, the beam gets bent due to the couple. Bending of the beam produces the couple. Due to deformation by the load, restoring forces are produced, tending to bring the beam back to its original position. It is again the property of the beam, because of its elasticity. When you remove the load, the beam will come back to its original position. Under equilibrium condition, restoring couple is equal to bending couple. When the beam is in equilibrium condition, the restoring couple and bending couple, they are of same quantity or having equal values. The plane in which the bending takes place is known as plane of bending. When you see the figure, the bending takes place along the downward direction along the plane. Such type of the plane is known as plane of bending. The section of the central surface AB by the plane of the bending which is perpendicular to it is called as neutral axis. As far as the neutral axis is concerned, it is that part of the beam where there will be no change in its length as far as bending is concerned. This line across the beam is called neutral axis. Now, when you want to determine the bending moment of a beam, when the beam is subjected to the load, under the equilibrium condition of the beam, internal restoring couple developed is equal to the opposite to the external applied couple. The internal and external couple developed across the beam under equilibrium condition, these two couples are equal. The magnitude of the moment of external couple is known as bending moment. As far as to determine the bending moment, let us consider a small part xy as shown in the figure of the neutral axis of the beam. Let the arc of the radius r subtends an angle theta at the center of the curvature O as shown in figure above. Let x dash y dash be another filament at a distance x from the neutral surface. Then xy is equal to r theta. This is very famous relation. Arc is equal to radius of curvature into angle theta. Similarly, we can also determine x dash y dash, which is equal to r plus x into theta, because x dash y dash is at a distance x away from the xy. Therefore, it is added with x, r plus x into theta. Now, by knowing these above two equation, increase in the length of the filament can be determined, which is equal to r plus x theta minus r theta, which is equal to x theta. By knowing this change in the length of the filament, we can determine the strain developed across the filament. Therefore, strain developed in the filament is equal to change in the length upon original length, which is equal to x theta upon r theta, which is equal to x upon r. Because original change in the length is x theta, original length of the filament is r theta, theta theta cancels and it comes out to be x upon r. Therefore, by knowing this strain, we can determine stress developed across the filament. Now, stress is equal to y into strain, because modulus of elasticity y is equal to stress upon strain. Therefore, stress is equal to y into strain, where y is known as Young's modulus of the material of the wire, which is equal to yx upon r. Now, consider the section of the filament A, B, C, D of the beam at right angles to its length and the plane of bending. Therefore, the line PQ lies in the neutral surface. The forces elongation acts in the upper half A, B, Q, P, and those of the contacts in the lower half C, D, P, Q in opposite direction perpendicular to the section A, B, C, D and form a couple as shown in the above figure here. See here, the upward portion is elongated and downward portion is contracted. Therefore, the couples are developed across this. To find the moment of couple, consider a small area delta at a distance x from the neutral axis PQ. Therefore, force on the area delta A is equal to small area delta A is equal to stress into area, which is equal to stress is known yx upon r into delta A. Therefore, moment of force about PQ is equal to yx delta A upon r into x, which is equal to yx square delta A upon r. Moment of all forces acting on various points of the faces A, B, C, D is equal to y upon r summation delta A into x square. We have to summarize all this delta A small area into x square, that will give the geometrical moment of inertia Ig of the section about PQ, and this is equal to AK square, where A is the whole area of A, B, C, D and K is known as radius of gyration about PQ. Therefore, moment of restoring couple is equal to y upon r A K square, which is equal to y upon r into Ig. Now, under equilibrium condition, restoring couple is equal to bending couple or bending moment. Therefore, bending moment is equal to Yij upon R. According to above formula, we can define bending moment may be defined as the total moment of all the couples arising in a beam and trying to rest its deformation caused by an external couple. This is known as bending moment. Thank you. Now next part we will see in the next period. Thank you.